Okay, so I'm going to record a video explaining the flight of a cricket ball and tennis ball. Mechanics question from the AQA. Alright, so pause the video and read the question if you haven't already. The question says, calculate the vertical speed of the ball the instant it left the bat. Okay, right. We are told that the cricket ball is hit by the batsman at 30 degrees to the horizontal, right, at a speed of 22 meters per second. Okay, some other information that's useful is it was caught at the same height as it was hit. Okay, right, so this is where it's launched. It's launched at 30 degrees to the horizontal, okay, at a speed of 22 meters per second, right, and we're being asked to find the vertical speed. Now, just sketching this diagram has immediately allowed me to see what the answer, what I must do. Okay, so normally in a projectile question you might be given this and then you're asked to resolve into its horizontal and vertical components. That's really all we're being asked to do, right? We can think of this vector as being made up of two vectors, one horizontal and one vertical, and we need to find this vertical component. Okay, so label up your triangle: hypotenuse, opposite, adjacent. I'm going to use the opposite and the hypotenuse, so that's sine 30 degrees, right, equals opposite over hypotenuse, and the hypotenuse is the actual number I have, and it's the opposite I'm trying to find. So if I multiply both sides by 22 sine 30 will give me the vertical component, and doing that on my calculator gives me 11 meters per second. Okay, so this answer is 11 meters per second. Units already given in the answer. Right, show that the ball was in the air for about 2.2 seconds. So here we go, the examiner's giving us a hand. They're telling us the answer in case we can't get it, in case we screwed up this first part, but I'm sure we can get it. So you could use the Suva equation for this. The key thing to recognize here is that since the horizontal component of velocity and the vertical component of velocity can be treated separately, this question is essentially the same as asking if you threw a ball directly up at 11 meters per second, you'd expect it to come down at 11 meters per second if you could ignore air resistance or treat it as though it's negligible. So that means that the change in velocity would be 11 meters per second, initial velocity minus final velocity, 11 meters per second minus, so that's positive 11 meters per second, minus negative 11 meters per second, which gives us a change of 22 meters per second. All right. So I can just use the standard acceleration equals delta v over t formula, rearrange for t, so that would become t equals delta v over a. The change in velocity is 22. 9.81 is acceleration due to gravity. And calculating this gets me 2.24 seconds and some bits and pieces. So basically, this is the working I would need to show, and yes, it shows that they are approximately the same, so I'm happy with that. I might even write this 2.24 is approximately, or it is basically 2.2 seconds. It's just rounded off. So that is fine. Okay, how far did the ball travel horizontally before it was caught? Okay, so what are we thinking about here? Right. So I've just worked out that the time it took was 2.2 seconds. If you look at this triangle, I'll draw it again. Okay. I knew that's 22, I know that's 11, and these are all meters per second. If I told you something had a velocity horizontally of whatever it is, a velocity, right? And I told you how long it was travelling for, you could just use speed equals distance divided by time to calculate the distance it would travel. This is essentially asking for the range. Okay, so I need to know the horizontal component of velocity, right? So I've got the vertical component of velocity, I have its actual initial velocity, I now need to get this here. So this can be done by Pythagoras, Pythagoras, sorry. So usually Pythagoras is c squared equals a squared plus b squared. Okay, and I have c squared and I have b squared, so I need to do c squared minus b squared, rearranging for a squared. Okay, take the root of both sides, cancels that off. So now I'm going to do 22 squared minus 11 squared, all rooted, will be equal to the initial horizontal velocity, which comes out at 19 meters per second. So now the question simply becomes, an object is moving at 19 meters per second horizontally, and it's doing it for 2.24 seconds. How far does it go? So speed equals distance divided by time. Distance equals speed times time. Okay, the speed is 19. The time, I'll just use the time they gave us, 2.2. Multiplying these together gives me 41.9 meters. Okay, so that's the range of the ball. All right, so really, all in all, pretty much a standard projectile question, but written in a different way. It's asking you to maybe calculate things a bit backwards, or not what you're used to, but if you just follow the instructions like you're doing an IKEA flat pack, don't think too much about why you're being asked to do each chunk of the question. Just provide the examiner with what they've asked for. Right, next part. Pause the video and read the question if you haven't already. A tennis ball is about the same size as a cricket ball, but has a lower mass. This is important, it has a lower mass. By considering energy changes, so let's think half mv squared, or it's going to be half little mv squared, right? Explain why the tennis ball hit at the same speed, the same angle as the cricket ball would be likely to reach the fielder without bouncing. Would be unlikely to reach the fielder without bouncing, right? So essentially they're saying a tennis ball wouldn't go as far. Why? Explain using energy. So you can start off by saying, I've actually written out an answer because my handwriting is terrible. So you can start off by saying a tennis ball has less mass, so it would have less kinetic energy at the same velocity, right? So that's kind of standard. Well, makes sense hopefully. It's also got a rougher surface, so it has greater air resistance, and since the ball is doing work against air resistance, the tennis ball would slow down faster than the cricket ball, right? And this would result in a smaller range for the same initial conditions, right? You can imagine why, because its horizontal component of velocity is going to get smaller, as well as its vertical and components, right? So it's going to have less time in the air, and it's going to be travelling horizontally at an average lower velocity, or lower speed. Right, so draw onto figure 2 the path you would expect the tennis ball to follow when hit at the same speed and angle as a cricket ball. So I'd imagine that it would be starting off almost exactly the same, and then as air resistance took its toll on the tennis ball more than it did on the cricket ball, I would expect the paths to diverge and the tennis ball to not reach the same height and to not get as far. Okay, so something like this. Okay, I hope you found this video useful. If you have, like, comment and share. Thanks for watching.